Okay. Okay. Desmond,
Yeah.
are you here, Desmond? Where is
Yeah.
your video? We are now live streaming with our friend here. Okay, there are so many people here. Okay, joining us. Okay, all right, Desmond, you are invited to join me for class today. I not be alone here. I have a friend, Desmond. Okay, thank you very much. Okay, thank you to all the student, Akmal, Rabiato, Sugar, Salwa, alright? So welcome to the class, okay? You can scan the attendance today. I will also send to your telegram that I send now, right? Okay, send already, okay? Alright, good morning to you all. We start the class, alright? The QR code, also I can send to your um, telegram as I send now. Alright, okay. Do not answer the games because we still not complete this class. After the class, you can answer the games. Alright, so this is not to answer for the early class. Okay, Desmond, how are you, Desmond?
Hmm.
Where are you now?
In Cebu, Sarawak.
Cebu. Wow, Cebu. How Cebu, Sarawak nowadays? How about the COVID pandemic
Okay.
in Cebu? I saw the data is only one yesterday.
Yeah.
Very
Okay
minimal.
lah, Cebu. It's
Yeah,
under control.
very good because I
The
saw it's
government
only
in the Sarawak is very strict lah.
oh, very strict. Yes, yes, I believe that. Right. I'm also received the message from MKN. We cannot allow to go to Sabah and Sarawak if they have detected with a convict. All right. So be careful. You all stay at home because nowadays there is, I think, the third wave, the increasing of convict population nowadays, I think four times, okay, four times as usual. In Johor Bahru, 100 per day, if not mistaken, all right? So I already checked, I'm regular check because I'm not going out, but somebody sometime come to my house. So I check, say, Alhamdulillah, negative convict, all right? If you feel not feeling well, go to any government hospital free of charge. Okay, in 2 days you can get the answer. Sometimes in 2 hours, okay, you can get the answer if you convict positive. All right, stay safe, right? Stay safe. Go to the online convict report to make sure that you are aware what happened to your surrounding, especially 1 kilometers okay around you. All right. So now let's we share screen. Okay, this month. I share screen. Okay. All right. I go to the directory. Here is the directory. December. We put here at the. All right. Okay. We share screen. Mm-hmm. Okay, 13 December. We share screen there on 15 December. Okay, showing that there is no response. I don't know why. Never mind. We try another alternative. Hang here. I don't know why. Wait for a while. Close first. Right, we share screen. Now, we go for this one. Share screen. And then we go to the live YouTube. All right. All right. So this one, I'm sorry because I have a problem with the my server. I'm not sure. Okay. So now I want to share screen. Okay. Again. Okay, the share screen to see. Alright. And then this is a PDF file. Okay. I'm also want to share with you the today class, okay, on the curfitting. Okay, let's we go to the YouTube. I hope all of you will together with me. Okay. All right. Okay. Here we learn about interpolation, Lagrange interpolation, linear interpolation in chapter 3. All right. So that's why my question here is what is my question? My question, okay, who has said that there is a permission. Permission means that you need to enter using, okay, you need to sign in through the Gmail to answer the question. All right. So the question there, what is different between curfitting and interpolation? All right. So through my class today, you can answer the question, what is a curfitting and what is the interpolation? What is different between chapter 3 and chapter 4? All right. Desmond, all right, Desmond, are you here, Desmond? Okay.
Yeah.
What you learn in chapter 3? What do you learn from chapter 3?
Chapter 3.
You learn what?
The
Yes.
Lagrange interpolation and the Newton difference forward and
Yes.
the backward.
Good, good. And then some more Newton backward, Newton forward. The data is a non-uniform. Am I right? Very good. So the same ideas and knowledge, okay, we want to transform to the curve fitting. What is a curve fitting? Curve fitting is how we generate the graph based on the data. All right. So the data, we train the data to generate a graph. There are two types of graph. The first is a linear. We train the data, we generate the data, okay, we generate the graph from the data as linear, okay. We force the data to be linear line. And the second is maybe we can, okay, obtain a quadratic or parabolic curve, all right, or parabolic curve. Okay, you can see here, okay, from here you can see, okay, when we have, okay, the data and then we transform to the parabolic, okay, means that we should know the optimum level. The optimum level of the graph is a zero, right? It's a maximum or minimum of the parabolic. All right. And then second, okay, we want to find the error between data the given in the question and then the graph that we generate, okay, through the curve fitting, and then the error is we call a square error, all right, and then the error should be minimum. Okay, when we said that the error should be minimum, means that, okay, the derivative of error should be zero. So this is the concept that we are going to apply the curve fitting to develop the graph, whether linear or parabolic. All right, so now let's we continue. Okay, for the least square, okay, method, okay, there are two methods that we're going to learn is a linear and quadratic, okay, least square methods, okay, least square method. Right, so meaning that we force the data to be linear or parabolic. Okay, the other method that we are going to learn is a linearization. What is a linearization? Right? The data is not in the linear function. For example, exponent is not linear. Parabolic is not linear. All right, and then ln is not linear. Okay, the cubic function is not linear. So how we can transform to the linear? So that is another topic under curve fitting we call as a linearization. So the difference between interpolation and curve fitting is, okay, interpolation, we are using a formula and then write the Lagrange or Newton, okay, based on the specific data. However, curve fitting, We are using all the data and then we train, we generate the data to be linear or quadratic, okay, or quadratic. So this is the difference between Curfitting and Lagrange interpolation or interpolation. All right, so now we continue. Okay, so when we have a data xiyi, okay, we can force or we can generate the graph, whether linear using linear least square method or quadratic least square method. All right. So now we go for the linear least square method, the first part. All right. We can also write the table xiyi into a set xiyi, okay, the set close from I equal to 0 up to n. So what is n? N is a maximum data in the table, or sometimes I say degree or order of the polynomial function. Okay. Now, let's refocus, Desmond. Okay, we focus here. Okay, how to generate a linear least square method? All right, because we know that x is an independent data and then y is a dependent data set. All right, that's given in the question, and means that when we set that linear least square method, we want to generate a linear line y equal to a plus bx. Sometimes you write as a y equal to mx plus c, right? Where a and b is constant or m and c is constant. It depends on you how you write a linear line. All right, so the next step, we want to determine what is A and what is B, all right, because we assume the data SIYI is a linear. So in this case, all right, I return back again, what type of this error, okay, what type of this error? We go to this error, yi minus yxi, what types of this error? Okay, this is a difference between, okay, when you go to the graph, yi is a data in the table, yxi is a graph from the linear least square method, right? So to make it positive or absolute, sometimes we are using squared, sometimes we're using absolute. So what is a yxi? Is a minus bxi, is a linear line. So the difference between the data yi and the linear line we call as an error. All right, we call as an estimation error. All right. So now, okay, okay, we want to find the summation error. How to do that? Because we want to determine x, a, and b. All right. So from LLS here, I said linear least square method. So S is a summation error. What is a summation error? Is a summation EI from data I equal to 0 to n, and I is a squared. Why squared? Because we want to make sure that the data is always positive. Okay, now I want to ask Desmond. Desmond, since you are my friend here, all right, why we need to find a minimum error? Why? Why we want to find S? S is a summation of the squared error. Why? Because
Yes, to find a constant.
because we want to find a constant A and B. Second, we want to minimum the error between the data and the graph that you are going to obtain. All right, we want to make sure that the data and the error, for example here, okay here. All right, so the data here and the error, the graph that you find from the linear least square should be close. All right, should be close and then converge to the approximation solution. So your approximation solution now is a linear least square method. Yi is a data. All right. So now we continue. Okay, S is an error. Summation error means that we want to make it all positive. So yi minus a minus bxi squared, okay, from I equal to 0 is a summation error. We call this one as a summation error. Ei is a error. So how to minimize the error? I told you the first class just now, we need to do the first derivative error respect to A and first derivative error respect to B, all right, and equal to 0. Why we need to equal to 0? Because error should be 0. Error should be 0. Alright, so the S over the A equal to summation yi minus A minus bxi squared. So we need to do a differentiate, the first derivative respect to A. So focus A. Differentiate negative A respect to A is a negative 1. Okay, del A over del A negative is a negative 1. So 2 here should be bring down. You will get, what you get is a 2yi minus a, okay, minus bxi power 1. 2 minus 1 is 1, negative 1. Okay, differentiate negative a is a negative 1 respect to a, equal to 0. So, okay, we know that when 2 you bring on your right, divided by 0 divided by 2 is 0. So the existing now is a summation a, summation bxi equal to summation yi. Bring yi on your right hand side, because you know this is the negative, okay, negative. So negative negative is a positive, negative negative, okay, is a positive. All right, and then bring your a is a on your right hand side, okay. Okay, y, okay, here you can see here, all right. Okay, this one is let's we go to y equal to a. This one is plus, yeah. Don't worry, don't please make it correction. This one is plus. When you have a plus, that's why you have a last matrix is a summation a plus bxi, all right, and then summation yi, all right, summation yi. So you can arrange this one, bring the constant A and constant B out of the summation, you will get summation 1, summation xi equal to summation yi. All right. We continue to find the error, the minimum error respect to B. All right. So the same formula, okay, you do the first derivative summation yi minus a plus bxi squared, okay, equal to 0. All right, so when you do the function of first derivative respect to b, 2 you bring down, 2 minus 1 is 1, okay, summation yi, okay, negative, okay, a, and then this one is positive bsi. This one is, you need to do a differential respect to b is a negative xi, okay, negative xi. All right, so when you bring 2 divided on your right here, okay, you can get 0. You will get summation xi, all right. This one is a plus summation xi squared. This one is, should be plus, yeah. Summation xi yi on your right hand side. All right. You bring the constant a, okay, summation si, bring summation b constant, summation si squared equal to summation si yi. So you have two equation now, equation 1 and equation 2. Since the parameter you want to find is a and b, you can transform to the matrix form, okay. So when you transform to matrix, okay, let's ask, okay, all of you, okay, this month, when we want to transform to matrix AU equal to F, you need to find what is U, okay, AX equal to F, what is X, what is F right answer on your part, okay, on your right part, all right. So can we arrange equation 1 and 2 into the matrix form? Can we do it? Can, am I right?
Can.
Because
Oh my.
A and B2
Yeah.
is like X and Y, all right? A and B2 is like X and Y. So this will be your parameter that you want to focus, okay? And then the rest you put in the matrix. Now let's we continue how we want to develop in the matrix form, right? AX equal to F, okay? How we want to develop the matrix form from equation 1 and equation 2. Okay, F is easy, summation yi, summation si yi. And then the parameter AB, put the as your x, okay, is a parameter. And then all the value on the summation 1, summation si squared on your left hand side as a A. All right, so now when you do this one, okay, you need to find summation xi, summation all the value of xi, summation yi, all the value of summation yi, all is given in the table. So please use your calculator. Okay, please use your calculator. Can you have bring calculator here? Can you bring your calculator? All right, so this is a calculator. All right, so you need to press, okay, you need to find the value of summation and then variant VAR, okay, and then you need to find REG, okay, regression REG, and then you need to find another one is insert value, okay, it's a linear, you need to find equation linear. If quadratic, you need to find equation quadratic. Okay, now let's we go. All right, so let's we focus here. Okay, let's we go to the example. Okay, we want to find summation si, summation yi, summation hi squared using the calculator. We really want to use manual because it will be wrong. It take time. So from the linear least square method for data given below, right? We want to find the summation error. Okay, the summation of the squared error is a S. Okay, we want to find S is equal to summation xi squared. Okay, what is S? S between the data yi and the linear squared method that you get from the matrix here. And then the second is we want to do all the calculation in 4 decimal places, right? And then how to answer this question, I put into a few steps. The first is apply the linear least square method, the matrix that I developed just now. And then second, find the value A and B by minimize the error. Okay, summation Si up to Si squared, minimize the error. And then the last is develop the table. Develop the table. Okay, in this case, the table should be okay in the vertical. All right, so we are transform the matrix, okay, the table to the easiest ones to perform in the least square method. Okay, you can see here the H, okay, between data of X is non-uniform. All right, you see X0 and X1, the H is 0.1. However, x5 minus x4 is 0.1. All right, x4 minus x3 is 0.4. So the H is not constant, meaning that the data is a non-uniform. Okay, now let's write the linear system for this data is equal to a plus bx. It's a linear. It's a y equal to a plus bx. All right. And then the data is given between SIYI, okay, in the table from I equal to 5. Okay, this is the way we want to find A and B. Okay, we know already from the linear least square method, okay, the matrix AX equal to F already generated, okay, from the first derivative as respect to A and B as given in the matrix here. All right, so this is already generated, okay, by minimize the error. Okay, so you have to know summation 1 from 0 up to 5 is a 1 plus 1 plus 1. So you need to know how to count this one. Okay, 1 plus 1 plus 1 plus 1 plus 1. All right. Okay, and plus 1 is a 6. Okay, how many value now? Summation 1 from I is equal to 0 to 5 is a 6. 6, okay, 6. You need to remember this one. All right. And then summation, let's say I want to do summation 1 from I equal to 4 is 5. Okay, summation 1 I equal to 3 is 4. All right, and so this is the way how we are representing the summation 1. Okay, now press the calculator. Go to your calculator, insert data. Okay, go your calculator. Come on, where is your calculator? Press mode fix 4. Find stat, find the linear a equal to y equal to a plus bx, and then insert data xi and yi. So this is very important. Okay, this one after you press that, you can get not linear, quadrat. You can also apply quadrat, but in this case, we still learn linear least square method. So you press linear and then insert that data. Be careful when you insert the data. Go to page 103. All right. Where is your textbook? Okay. Go to page 103. Where is 103? Okay. They teach you how to press. Okay. Mode fix 4 and then press tab and then press number 2 to find a plus bx and then insert data x, insert data y. Insert data x first and then insert data y. Alright, so means that you generate the table and then go to the shift stat again, find var, okay, variance, okay, variance, find var. Alright, so now let's find var. Can you get the var? Find var, find sum, and then find reg, okay, regression, right? So variant n equal to 6, summation from I equal to 0 to 5 is 6, summation xi is at 8.8. You press summation, and then summation yi is equal to 13.2, summation xy equal to 20.345. Okay, can you do it? Come on. I don't want you to left it. Find. Okay, the data is given in the page 103. So please find. Please try to press. Okay, what is that? Step. All right. Some more. We need to use linear. Okay, linear. Linear is number 2 in my calculator. Maybe your case is maybe different. And then insert, okay, x and y. All right. After that, find var. Okay. You need to use stat. Okay. You need to use find var. And then find sum. And then find reg. You know why? Because we want to find what is the value of a and b. Okay, this is important. All right, this is important. Please try. Okay, press tab, linear. Before that, you need to use stat shift. Yes, you need to use stat shift. 103. You go to 103. Okay, you need to use the stat, okay, shift stat, whether 4, 3, or regression 5. Regression 5 is to find what is the value A and B, straightforward from your calculator. All right, straightforward from your calculator. Okay, now let's say you success to find xi, siyi, xi, yi. All right, so now you press regression, reg, you can find A is equal to 0.5070 and then B is a 1.1543. However, you need to insert in the table. No need to write what is a summation xi. For example, I is a value that given 1.1, okay, 1.1 squared, 1.3 squared. No need to find the value for every particular value for I equal to 0, 1, 2, 3, 4, 5. All right, why? Because we just want to find the summation yi, summation xi, and summation xiyi. That's all. All right, and then insert in the matrix, insert in the matrix, okay, AU equal to F just now, and then from your calculator you know the value of regression A and regression B, just insert in the matrix. Without insert in the matrix, we don't know how you find A and B. All right, however, okay, you are using calculator to find the whole step. You need to have a calculator to find the whole step. All right, so in this case, okay, what we want to express here, we want to express here the data that you get. Where is the data? The data in the question, the data that you get here is a linear line. Is a linear line by finding the summation si, summation si squared, summation yi, summation siyi from the calculator, and then arrange the matrix, okay, ax equal to f, okay, and then is equal to 13.2, 22.345, and then A and B you get from the calculator. Okay, all right, you get from the calculator. So this is the linear line. So set in your mind, you already train, you already obtain, you already generate, okay, the data as a linear line. You force the data to be a linear line, all right? You use all the data, and then you generate the linear line based on the least square method. Okay, least square matrix, like you write y equal to mx plus c. What is c? 0.4507. What is the gradient? 1.1543 is a linear, is a positive. All right, so now I would like to ask a question. How to present data given in the quadratic least square method? So this is my question. All right, we go to Desmond. Okay, Desmond, just now we given you 5 data, xi, yi. Am I right? So
Yeah.
now can I present this data as a quadratic form, as a parabolic graph? Can I do? Just now I just write in the linear line. Can I make it in the quadratic
Yeah.
picture? Huh?
Quadratic picture.
Can?
Okay.
Kan?
Yeah.
Boleh tak? I
Boleh.
can write the data into the quadratic form. Am I right? Okay. So when you said that yes, so how to do that? Okay. So we are using a similar step. What the first step? The first step is we assume the quadratic is a power 2, yeah? A plus bx plus cx squared. And then second, we want to minimize S. What is S? S is an error between the data and the quadratic least square method. All right. And then the third is we want to develop the matrix for least square method. Right. Of course, after that, we want to use calculator to find summation 1, summation si, summation yi, summation xi power 2, summation xi power 3. All right, using the calculator. Okay, so now get ready. Get ready to press what? Get ready to press shift mode, fix for mode stat, okay, is a quadrat, a plus bx plus cx squared, and then insert the data. Okay, I want to find the data. Where is the data? The data is at the previous step. Okay, we are using a data the same as we solve using linear least square method. All right. So before this, okay, I want to ask at the Macam mana ni anak panah apa ni tulis anak panah macam what Akmal, I'm not sure. Ya, anak panah je lah Akmal, because anak panah tu is for the step we want to go in. So when we go to the least linear square method, okay, we want to compare with the quadrant least square method, okay. So can you set in your mind what is the difference between linear and quadrant least square method? Linear, okay, the data that we have, we train to the straight line. Okay, nampak anak panah tu kan? Anak panah tu maksudnya ialah straight line, y equal to mx plus c. Alright, we can also train the data, we can obtain the graph or the function of quadratic least square method from the same data. Alright, so now we can find the error, which one is close to the data in the question. Okay, so this is different. Second, okay, quadratic least square method involve many computational because the matrix is a 3 by 3. Linear is a 2 by 2. So it involve high costs. And then second, quadratic linear least square method is much more better than linear because okay, they follow the curve. If linear is a straight line, okay, it's a straight line. All right, so quadratic is a curve with the maximum, or you can find is a minimum. It depends. All right, so now let's continue. Okay. Okay, we want to develop the matrix through this 4 step. Okay, anak panah tu 4 step tu lah. Alright, what is the first 4 step? The first is what is now? We assume the quadratic is equal to a plus bx plus c. Okay, we assume. Alright, we assume. Alright, and then let's focus. Alright. The error, as usual, is a yi minus yxi. This many times we do. Alright. Error is a difference between data and the quadratic least square method. Okay. And then we want to find error squared, always positive. Sometimes the error is negative. We put in the positive manner as I squared from I equal to 5. Data we have now is 5. All right, and then we fit in all the ei equal to yi minus yixi. Okay, we fit in this one and put square. All right, since you have a, b, c, so to make it small, ds respect to a, ds, okay, s, first derivative f respect to a, first derivative s respect to b, and first derivative s respect to c is equal to 0. Same as a linear before. All right, so yi minus a plus bx plus cx squared. This one I just put negative. Okay, it should be yi minus, so all is a negative squared. All right, and then let's apply the first derivative s respect to a, okay, is equal to 0. Okay, we do the first derivative s respect to a, and now the s respect to b is equal to 0. This is 3 steps we need to do because the graph is a quadratic. And then the s over the first derivative s respect to c is equal to 0 too. All right, so now let's do the derivative one by one. Respect to a first, okay, respect to a is a negative 1, all right. 2 here you bring down, and then 2 minus 1 is 1, all right. So times negative 1, okay, because we do a first derivative respect to a is a negative 1. Okay, the place is not here, so I bring negative 0 on my right, okay, hand side, okay, far away there, so I can insert negative 1, right? Respect to a is a negative 1. I'm also, okay, using the same step, derivative summation si squared, okay, respect to b is a negative xi, all right? And then power 2 should be, okay, 2 bring down, 2 minus 1 is equal to 1. All right, so times negative xi, okay, times negative si because we respect to b. Now the third, okay, the same one, okay. All right, we are doing derivative to bring down yi minus a minus bxi minus csi squared. All right, power 1. Respect to c is a negative xi squared. Okay, negative xi squared. So this is the we need to do is to minimize the error respect to a, b, and c. And then you can perform in the matrix. Okay, make sure, okay, ax equal to f, so your right hand side, and then the x is a b, c, all right? And then the matrix A is a summation 1, okay, summation xi squared. This one is you can follow A, B, C, all right? So the um, constant, okay, the value to times A, okay, on your right hand side, don't worry, you bring summation yi, summation summation si squared yi to your right hand side, all from this matrix. 2, okay, 2 you bring on your right, 0 divided by 2 is always 0, all right? The element for matrix A here is a summation 1, okay, summation 1 because you times A kan, summation 1, summation xi times B, summation xi squared times C, all right? The same manner, summation xi, summation xi squared, summation xi cubed, power 3 times C, all right? And then the last, okay, is a summation xi squared, summation xi power 3, summation x1, xi power 4. You can see x power 2 times power 2 is x power 4. All right, so this is the standard matrix form for the quadratic least square method, right? So when we want to find, okay, the quadratic, so you need to find what is the value a, b, and c. You need to find the summation si, yi, and si, all the value you need to do a summation. So my question here, all right? So we go to the question here. Okay, we go to the question here. Okay, my question is how to generate the 3 by 3 kan, okay, 3 times 3 ax equal to f. The matrix linear is ax equal to f, all right? So how to do that? Okay, this is my question. How to generate 3 by 3 matrix ax equal to f? How many steps? How many steps? Okay, how many steps? So this is my question. How many steps you need to find? The first is you assume quadrat as a plus bx plus cx squared, meaning that parabolic. The second is find the error. Error is between data and the quadratic, all right? And then the third is minimize the error. Error is a xi squared respect to a, b, and c. All right. So this is your step that you need to follow, right? So I'm afraid, okay, they ask you to create the formula of the linear least square method, all right? So you need to go through all the three steps. That's I'm afraid, all right? So they ask you to obtain the formula, right? To find the formula. That's I'm worried. So if not, you need remember, okay, what is the next step from here? We give you example, and then you need to find what is summation xi, summation yi, summation si squared, summation si yi, summation si power 3, summation si squared yi, summation si power 4. So this is I'm afraid, right? How to do that? Use the calculator. Okay, go to the calculator. Where is your calculator? Come on. How many times I said? Stat and then find the quadrat. a plus bx plus cx squared, not linear, not linear. All right. So press your calculator now. Okay. Using the same example, I'm using the same example because I want to compare which is much more better, whether quadratic or linear square method. All right, so now, okay, again, we are using the stat, var, sum, and reg to find A and B, C. All right, so we go to the next question. We have the same data, 1.1. Okay, what is the data? Okay, you go to page 106. Okay, we are using the same data. We are not make it more confused. The data is uh, okay, the same data. Okay, is a SI, S naught is 1.0, 1.1, 1.3, 1.5, 1.9, and 2.0. Y naught is a 1.46, Y1 is 1.67, okay, 2.31, Y3 is a 2.45, Y4 is 2.5, and Y5 is 2.81. All right, so you know that. Okay, the value. So now use quadratic least square method, okay, to obtain the graph, okay, to generate, okay, the quadratic form y equal to a plus bx plus cx for the data given, so now that's why I'm stopped here. I want to ask a question again. What is the difference between the interpolation that you learned before and square method, linear least square method, okay, that you learn now. Okay, so you can answer this question. Please, imagine interpolation, Lagrange interpolation. Okay, you are using all the data, and then you use this formula of Lagrange by introduced through the interpolation. And then now least square method, okay, you are train the data to the matrix and then get the value, and then you transform the matrix to the linear system or quadratic system. So you can see what's different. All right. So when I ask a question, okay, what's different interpolation and linear least square method or quadratic least square method, you can answer. Kan? Desmond, you can answer, eh? Am I right, Desmond? You can answer based on the data given. Okay, now let's continue. Let's continue here. Okay, we want to find the summation error, summation squared error from the I equal to 0 up to 5. All right, so in the same time, okay, you need to find the value of the data. Okay, press your calculator, use that, use quadratic, y equal to a plus bx plus cx squared, insert data xi and yi, find variant, okay, summation 1 from I equal to 0 to 5 is a 6. 1 plus 1 plus 1 plus 1 plus 1 plus 1. So the answer is 6. Summation x is as usual in the linear, you can now know what is summation x is a 8.8. Summation xi squared 13.76. Summation si power 3 22.762. Summation power 4, okay, is equal to, okay, we start I equal to 0 up to 5, kan? 39.4148. Summation yi, okay, is similar to the linear, 13.2. Summation siyi also similar with the linear least square method, okay, is a 20.345, and summation xi squared, okay, xi squared y is a 13.1621. All right, so the regression, the value, press regression, you can get the value A, you can get the value B, you can get the value C. So this one is just use the calculator. However, to make sure that I can give you a marks, okay, based on the step of numerical, in manual. So you draw the table. Okay, you draw the table. So this is a matrix of the quadratic least square method that you need to replace. Okay, for this matrix, all the element A is a summation 1, summation x, summation si squared, summation xi, summation si squared, summation si cubed, summation si squared, summation xi power 3, summation si power 4. So you can see the pattern. It's similar. It's the same. It's a simple. It's as easy to remember. All right. If then you know proof. And then second, you draw the table. Okay, because we want to see the location of the summation Si. Where is the location of summation Si? Where is the location of the summation Yi? All right, from the table. Where is the summation of the Si power 4? So, okay, summation from I 0 to 5, 1 is a 6. Okay, you need to know. This is a 6. 1 plus 1 plus 1 plus 1 plus 1 plus 1. This is 6. Okay. So don't need to write the element, you just drag the arrow, panah-panah sajalah. Okay, letak je panah because you have no time, you know the answer. Okay, you no need to times xi power 2, 1.1 power 2, 1.3 power 2, no need. Alright, you just put anak-anak panah je. Alright, so this is a question. Okay, tadi kata apa? Letak-letak je ya, lurus-lurus anak panah ya Akmal. Yes, because you have no time to write all the specific element in the table. Actually, you get from the calculator. You get from the calculator. You get from the make sure you need to press the calculator very fast, accurate and efficient. Okay. Okay, bukan tak anak panah je ya. You need to find all the value of summation x power 2, summation x power 3, summation x power 4 should be what? Should be okay, accurate and then efficient. Okay, accurate and efficient. So get from the calculator. Alright, so don't say that you just use anak panah saja. Alright, so how about this Desmond? Alright, so now Desmond, do you need to insert all the particulars y1, y2, y3, x1 squared, okay, x2 squared, all right? You need to write or you don't need to write, all right? The answer, no need, because all the summation of xi, yi, you can get straightforward from your calculator. Very good, Desmond. Thank you very much. All right. So now we continue. Okay, from the calculator, you know what is A, B, and C. However, you need to write in the matrix form. Where is A? Where is B? Where is C? What is the value of F? And what is the element of A? All right. So you write, you match, okay, you fit all the value from the table to the matrix form. All right. From the matrix form, you can get the summation xi is a 8.8, summation xi squared is a 13.76 until summation xi power 4 is a 39.49414. Alright, so by using the calculator, alright, you can get the value of A, B and C. Alright, so this is the very simple, and then I hope that you can go to the exercise 4.1 and 4.2. Okay, let's go to the exercise 4.1 and 4.2. Okay, go to 4.1 first. Okay, very simple. 4.1. Okay, it's about let's go to 4.1. Okay. You are given many data. You see data number 4 is too many. 1, 0, 1, 2, 3, 4, 5, 6, 7. 7. There is a 7 data. So summation from I up to 7 is 8. Is 8. Alright, so the matrix is If you want to use linear line, 4.1 is a linear least square method. So the matrix is a 2 by 2. Okay, 2 by 2. 4.2, exercise 4.2, page 110. All right, the data is up, also the same data. It's a 7 data, meaning that summation from I to 7 is equal to 8. And then in this case, you need to find the ABC. So the matrix is a 3 by 3. All right. So what you learn now is if a linear least square method, the matrix is a 2 by 2. Okay, 2 times 2 matrix. Okay, okay, a matrix. However, quadratic least square method, you are using 3 times 3. Okay, you are using 3 times 3 matrix, okay, matrix size. Okay, because you need to find the value of A, B, and C. Okay, A, B, and C. All right, so this one you need to remember. Okay, when you do the curfitting based on the least square method, whether quadratic or linear. All right. So I'm stopped here. Because I want to ask. I'm waiting for the any question. Any question? We have any question? Right? My spelling also wrong here. All right. So let's go to any question. Okay. No question? I'm waiting you to write a question. Is it too fast? Until now, you cannot understand my class? Okay, let me know. All right. I want you to go to the e-learning. Go to the e-learning. All right. Go to your subject. Okay. 2423 kan? All right. Go to the subject. And then I want to share with you. Stop sharing. Stop sharing. I want to share with you the e-learning. Go to the e-learning. Okay. Yes, here. Okay, we go to the e-learning. All right. So when you go to the e-learning, all right. So I welcome you. I welcome you because now you are you have your 1 week holiday. Now I welcome you come back to here. And then I also send you the application of the nonlinear equation that we have a small talk by Dr. Fiza, all right? By Dr. Fiza, you can click there, you can see how the presentation, how many people vote. Okay, for this presentation is much more very fast here. Okay, you can see very fast. Okay, voting here. I'm very happy. Okay, very. Okay, I share screen. Okay, all right, you can see here. Okay, now we drag down. Okay, you can go to the at 13th of December. I send you the PDF file of the curfitting, and then this is your question. Okay, this is a question. Okay, be careful. Okay, when you want to answer this question, be careful because okay, we go to the question. Okay, be careful. Okay, you need to sign in. To go to the question, you need to sign in. All right. Go to sign in. All right. So find the question there. Okay, but you need to sign in. All right, and then second, let's we go to the okay, back again to the e-learning. All right, so this is a material. All right, I will post you most of the lecture at the YouTube or the download from the YouTube. Okay, so there is any question here? Can I have any question? Okay, any question from the uh, student out there? Any question? Okay, there is no question. Okay, Desmond, do you have any question, Desmond?
No.
Okay, no question, yeah. Okay, so spend your time to do the self-determined learning. Spend your time to understand. You can go to the e-learning. Okay, I'm helping you how to learn the chapter 4. You go to chapter 4 here, you can see. Okay, you can see chapter 4 here. You click here. There is a zip file. I prepared here, zip file. Why? Because they are full of chapter 4, chapter 5, chapter 6, chapter 7, and chapter 9. Alright, so you click here. So the second is, okay, we are always go to your Telegram to post the link of the previous class. Okay, we are using YouTube, so your class always at the YouTube. Alright, we no need to okay to do that. Alright, to transform to the okay, so now, okay, wait, okay, the question from Salwa, need permission. Need permission, I will allow for the permission, but you need to go, you need to sign in using Gmail, okay? Okay, never mind, I go back, okay, I will try to, where is your, okay, Telegram here, okay, need permission, okay, I will okay, I will try, I send to the Telegram already. All right. So now I'm waiting you to answer the question by today. Okay, by today through the Google form. All right. So take time, take time. You can send till night. Okay, till night. Take time, which is your answer. All right. Okay. Yes, cannot open. So I will make a permission to you all. Okay, so thank you very much. Okay, thank you very much. Any question? I send through the YouTube. Whatever answer I send to the, whatever lecture I send to the YouTube, whatever answer I send to your Telegram. For example, for today class, kan, you can see my class today, all right? The last feedback I sent, okay, most of you said that, come on, we go to the Telegram. I'm not happy. How many percent I'm not happy here? Okay, Newton divided, Newton Lagrange is a uniform or not uniform? Not uniform lah, kan? So 35.6, this is wrong. Okay, come on, do a revision. And then I give the question on the Lagrange. Okay, so that is a Lagrange. Okay, so 12% is not, correct. And then 88.1, okay, from the formula, how to generate order tree. Need more than data, use, okay, just use the formula from the order 2, calculate the formula again by including, so the yellow color, okay, very good. Need more data, okay, green color also good. Recalculate a new formula, the purple color, very good. And then the blue color, light blue color, use the new formula for order 3, is very good. So understand, most of you understand, all right? So question 1 and question 2, some of you, 35% and 12% cannot understand. Okay, please do the revision because we are going to have a test 2, okay, on the chapter 3, all right? Do the revision. So come on, go to your Telegram, okay, find the answer. Okay, thank you very much. Okay, so now this one I will answer. Still cannot open. Wait. I'm teaching. Now I'm the class. After this, I'm correct the Google form. All right, Nisa. Okay, also here I will open it. I give you permission. You can answer towards the end. Okay, towards the before 12. Okay, midnight. All right. Bye-bye. See you at the Telegram. See you at the Telegram. All right.